Hi, so we are going to look at this question. The question is saying, let the functions r to r be defined as fx is equal to e power x minus 1 minus e power minus of mod x minus 1, gx is equal to half e power x minus 1 plus e power 1 minus x. And you have to find the area of the region in the first quadrant bound by the curves y is equal to fx, y is equal to gx, and x is equal to 0. So how do we go about doing this? So to find the area of the curves, I need to have some understanding of the graph of these functions. And we have to find only area of the region in the first quadrant. So I only care about the graph in x is greater than 0, right? So let's try to draw the graph of the function. Notice that this function can be simplified and written like this. Fx is equal to e power x minus 1 minus e power x minus 1 if x is in between 0 and 1, and it is e power x minus 1 minus e power minus x plus 1 if x is greater than equal to 1. Here I am removing the mod. This is equal to minus of x minus 1 if x is less than 1. So in that case, since it is a minus of mod, so it becomes simply x minus 1. So the function fx is simplified as 0 if 0 is less than equal to x is less than 1, and as the e power x minus 1 minus e power 1 minus x if x is greater than equal to 1. So this is a fairly easy graph to plot. This graph will look like it is 0 till 1, and after that it will rise up like this, right? So this is your fx graph, and this is x is equal to 1. Now for the gx graph, if you think about it, gx is half of e power x minus 1 plus e power 1 minus x. So notice that g of 1 will be equal to half of e power 0 plus e power 0, which is equal to 1. And g of 0 will be equal to half of 1 by e plus e power 1, and g of 2 is equal to half of e power 1 plus 1 by e. So you are getting g of 0 and g of 2 are equal, and g of 1 is 1. So g function is symmetric about x is equal to 1. So the graph can be drawn for the g function somewhat like this. G function graph will become like this. X is equal to 1 is here, x is equal to 2 is here, and this is 0. So at 0 it is some value, at 1 it is 1, and at 2 it is the same value. So you will have a graph somewhat like this for g of x. Now notice that f of x is like this. F of x was like this. If I draw it here itself, f of x is like this, and it is going to cut somewhere here, right? So the area of the function will be this region. If I know the point of intersection, I'll be able to find the area. Someone could have a doubt whether these two curves will intersect again. You can check that by checking slope of f and slope of g. Slope of f and slope of g will be found by taking a derivative of f and derivative of g. If you take the derivatives, you will realize that slope of f is greater than slope of g. So f graph will rise much faster than the g graph, and therefore they will never intersect after this point. So the area that we seek is between x is equal to 0 to whatever is this point of intersection. This point of intersection can be very easily calculated. So I will just do that now. And I will do that by solving fx and gx. So I'll just rub off some space here. When you solve, you will equate fx and gx, and you will find the value of that intersection point. Once we know the intersection point, it's a very straightforward area question. E power x minus 1 minus e power 1 minus x should be equal to half of e power x minus 1 plus half of e power 1 minus x. So this becomes e power x minus 1 by 2 is equal to 3 by 2 e power 1 minus x. This cancels, and you get e power x by e is equal to 3e by e power x. So this becomes e power 2x is equal to 3e square. So you get 2x is equal to log 3 plus 2. So x is equal to half log 3 plus 1. So x is simply 1 plus log root 3. That is my intersection point, 1 plus log root 3. So let's use that now to integrate. And we know that fx is above gfx after that intersection point, but before that fx was below. So the graph looks like this. Graph of g looks like this. Fx is 0 till 1 and then it rises like this. So this point is 1 plus log root 3. So the area is simply the integration of gx minus f of x, right? So I'll split that integration into two halves. Until 1, my gx was this and fx was 0. Integration area will be 0 to 1 gx dx plus 1 to 1 plus log root 3. This is gx minus f of x. Gx minus f of x dx, right? So I will do the integration on the next page, or at least or here itself. So what is coming out? Let's see. Area is equal to 0 to 1 g of x dx. Let's do this part first. This part becomes 0 to 1. G of x is half of e power x minus 1 plus e power 1 minus x by 2 dx. This becomes e power x minus 1 by 2 plus e power 1 minus x by minus 2, and evaluated from 0 to 1. When you put the values here, this becomes half of e minus 1 by e. So you can put the values yourself. It will come as half of e minus 1 by e. Now what we have to do is the integral of gx minus fx, right? So gx minus fx will become half of e power x minus 1 plus half of e power 1 minus x minus e power x minus 1 plus e power 1 minus x, right? So this is 3 by 2 e power 1 by minus x minus 1 by 2 e power x minus 1. So I will just rub off some space and do the integration here. Just remove this diagram. This second integral is basically integral 1 to 1 plus log root 3, and this is 3 by 2 e power 1 minus x minus half of e power x minus 1 dx. So the integrations are fairly straightforward. 3 by 2 e power 1 minus x by minus 1 minus half of e power x minus 1, that is after integration. Now we'll put the values 1 to 1 plus log root 3. So what is the value that will come? Let's write the answer. So minus 3 by 2 e power 1 minus 1 plus log root 3. So it is minus log root 3, right? Then minus half e power 1 plus log root 3 minus 1. So it is e power log root 3, right? Then minus 3 by 2 e power 0, and then plus half e power 0, right? This is what is coming. So let's try and evaluate that now. If you evaluate this, what you get is this is equal to, this becomes minus 3 by 2 e power, in the denominator e power log root 3 becomes simply root 3. This becomes minus half, in the numerator root 3, and this becomes plus 3 by 2 plus half. So that equals 2 minus 3 by root 3 becomes root 3 by 2. This is root 3 by 2, and this is minus root 3 by 2. So it becomes 2 minus root 3. So we are getting 2 minus root 3 as the area to the left, to the right of x is equal to 1. So we had the functions were looking like this, f was looking like this, and g was looking like this. This was the point 1 plus log root 3, and this was the point 1. So the total area was this area plus this area. So this area we have evaluated in this integral, the first integral, it came as half of e minus 1 by e. And the second integral is the answer of this area, which is 2 minus root 3. It comes by taking the difference between the gx function and the fx function and integrating it under these limits. So that gives us the answer 2 minus root 3 plus half of e minus 1 by e, which is the option A. So option A will be the right answer for this question. And I hope that answers it for you.